The next one is your what is an algorithm. I will be taking, but the main topic over here is that what do you mean by the complexity of the algorithm, and whenever any algorithm is given to you, how to find out the complexity of that. Okay, and this topic is very important one because your first unit is mainly related to that how to find out the complexity of any algorithm. First thing is that what is an algorithm? So you are already aware of that. What do you mean by an algorithm? Like you can say like it is a step-by-step method to solve any problem, or it is a well-defined computational procedure. Like you can say procedure, or you can say it is a step-by-step method that you need to write down whenever you want to solve any problem. Okay, so whenever you are having any algorithm, suppose you are having and you want to solve any problem, for that you may need two things. One thing is input, another may be sometimes you need data. So you're providing the input to this algorithm. Input means suppose if you want to find out the sum of two numbers, suppose you have written here the algorithm to find out the sum of two numbers. So you need those two numbers. You need to ask the user that what are those numbers that you want to add, and what you will be getting, you will be getting some output. Okay, so an algorithm will take some input. Sometimes you don't need an input, so you just want to display something. So in that case, you don't need that input. But mostly in many problems that we will be doing, we need the input. When you're giving the input to the algorithm, you're getting some output. So what is an algorithm? Algorithm is a step-by-step method to convert or to transform this input to the output. Suppose if you're giving two number, 2, 3, it will transform those two numbers to 5 because it is taking the sum of those two numbers. Okay, so you are already aware of that what is an algorithm. Okay, so next one is that algorithm complexity. Complexity, this word, whenever I'm using complexity, means what now? Or like this word can be used analyzing an algorithm. Suppose if I'm saying you need to analyze your algorithm, anyone who can tell me that? Now, whenever I'm saying analyzing an algorithm, first thing is that what's the meaning of analyzing an algorithm? Now, analysis of algorithm means we need to find out two things, not one only, two things. Okay, what are those two things? We need to find out how much space will be taken by the algorithm and how much time will be taken by the algorithm. So whenever you are saying that what is the complexity of the algorithm, or if someone asks you what do you mean by analyzing an algorithm, you won't only say that it means that how much time will be taken by the algorithm. It means two things: how much time and how much space will be taken by the algorithm. There can be some other resources also, but we won't talk about that. Other resources can be like bandwidth. Okay, how much bandwidth is required or something like that, but we won't be taking those things. Okay, so analyzing an algorithm means predicting the resources that algorithm requires. Now, which resources? I'm talking about two resources: space and time. Now, whenever we say space, that means how much space will be taken by the algorithm. Suppose you want to execute that program. So you know this thing, whenever you have to execute your program, firstly your program will be shifted from hard disk to your RAM. So here I can say that what is a space complexity? Space complexity means how much RAM is required by your algorithm. But nowadays there is no problem of space, because hard disk, if you want to buy, or if you want to buy RAM, that is not very costly. Okay, so whenever we say that how much space is required by the algorithm, that means you assume that how much RAM is required. Okay, but the space complexity, again I'm saying, is not a very big problem nowadays. Why? Because the hardware is not very costly now, it's cheap. So whenever we see algorithm complexity, we talk about mainly the time complexity, mainly about this time one. Okay, so time complexity means how much time will be required by the algorithm to execute. Okay, now I think Ajit was saying that the time taken by the algorithm means mostly students say that we need to measure in these units like milliseconds or microsecond. Suppose you are going to run your algorithm, you are going to check that how much time it has taken, how many milliseconds or how many microseconds your program has taken. No, but Gigi, that is wrong. Okay, all others who are thinking that we can measure the time in these units, that is the wrong thing. Okay, so here I have written, whenever you are saying how many seconds are taken, or if you're using any another clock measurement like microsecond, that is the wrong thing. So what do you mean by the time complexity? Time complexity means how many operations are being performed by your algorithm. So please remember this thing. Again, this is not right. I'm going to correct this definition. Okay, I'm going to refine that definition in my next slide. But right now you can assume, what do you mean by the time complexity? Time complexity means how many operations are being performed by your system, by your algorithm. Okay, so please remember this thing. Any doubt in this? Okay, so next thing is that now, whenever we write an algorithm, obviously, if your algorithm is very small, like I had told you, suppose if you want to add two numbers, in that case, we are not performing a large number of operations. We just need to add two numbers. We can say mostly two or three operations are being performed. That is fine. But if your program is very large, in that case, we will be performing a large number of operations. Even if you are writing something like this, na, A is equal to B. Suppose A is equal to 5, I have written. Here also we are performing one operation. What is that operation? Assignment. We are assigning 5 to A. Okay, but whenever we are analyzing an algorithm, we don't need to count each and every operation. What we need to count, we can take the key operations. Key means the main operation, significant. Like I'm writing here one word, significant operations. Okay, now you can ask me that, what do you mean by the who is there? Please keep yourself muted better. Okay, so what I was saying, we don't need to take each and every operations, we need to take the significant operations. Now what's the meaning of the significant operation? Suppose like some elements are given to you, and you have to search for a particular element, like we have already done linear search and binary search. Now in case of searching and in case of sorting, what is the main operation that we perform? Like in case of linear search, suppose I have given you some elements, and I'm saying find out whether 12 is present or not, or whether 30 is present or not. Okay, what we do, we compare our 30 with 25, then with 12, and then with 13. So what is the main operation that we are performing? We are performing the comparison operation in that. That means in case of searching and sorting, whenever we have to find out the time complexity, we need to find out that how many comparison operations we are performing. Okay, so if you are performing a very large number of comparison operations, you can say its time complexity is high. But in case of suppose binary search, if number of comparisons are reduced, we will say the time complexity is less. So in those algorithm, we don't need to take some simple operation like assignment, or aap kahin plus minus kar rahe ho, so that is okay. We don't need to take those operations because most of the time in these algorithm would be spent in comparison. Okay, so we need to take those operations, right? This is right. But again, I will say, okay, even if you are telling this definition of time complexity, to large extent, that is right. That is right. Fine. But what is the exact definition of time complexity? That means we need to find out the growth rate. Growth rate is what? We need to find out that as you are increasing the value of n, N means the number of elements, how the number of operations are increasing. Suppose जो significant operations है, how they are increasing. Suppose now again take example of linear search. In case of linear search, if you're having just 5 elements, so I need to perform a maximum of how many comparisons? Obviously you say 5. Okay, suppose the number of, if n is 5, you are saying the operations that you are, comparisons that you are doing, that is 5. So you can say time complexity is 5. But if you are having 100 elements, how many operations you need to perform? Obviously 100. Okay, so time complexity will become 100. But if suppose you are having 1 lakh elements, in that case, how many significant operations you need to perform? 1 lakh. Okay, so what you will say, आपकी complexity क्या है? 5 है, 100 है, कि 1 lakh है? So that means you can't say your time complexity is 5 or 100 or 1000, because we are not interested in that. Suppose आप linear search का algorithm किया, suppose if I'm asking you, okay, what is the time complexity of your algorithm? Suppose if you are taking the 100 elements, student will say it is 100. Actually, that person is right. But 100 is not in the generalized format. क्योंकि अगर दूसरा स्टूडेंट 1 लाख एलिमेंट्स ले रहा है, तो that person can tell me, no ma'am, the time complexity is not 100, I'm getting 1 lakh. So that person is also right. So you can't say it is 100 or 1 lakh or 1000. So what's the meaning of time complexity? Time complexity means what is the relationship between these two things. That means as you will increase the value of n is what? Number of elements, how the number of operations are increasing. Suppose if your number of operations are increasing in the linear order, you are getting this straight line, you can say the time complexity is linear. Linear means as you're increasing the value of n, your significant operations are also increasing in the same order. So that is called the linear relationship. So instead of saying now 100 or 1 lakh or 1000, if you will tell me that the time complexity is linear, that is the best way to define the algorithm complexity. Okay. Okay, now I'm drawing one graph. Suppose now, beta, I'm asking you that during the second wave of COVID-19, when COVID-19 was at the peak of first wave or the second wave, what was the relationship between the number of patients or the population and the number of COVID patients? What was the relationship when that COVID-19 was at the peak? Can you tell me that? You must have seen that graph during in the newspapers, or if you are listening to the news channels, you must have read about that. Okay, what was that? Gurjot is saying it was directly proportional. Yes, anyone else? I'm saying when it was at the peak, during the peak time. Yes, Vishal, can you tell me during the peak time, how the COVID-19 patients were increasing, the patients who were having the positive, who were positive? Yes, anyone else? That was not linear, Rajay. That was not linear. That was increasing in this order. In this order. Okay, not with the number of patients. Okay, sorry. With time, like suppose if you are taking with time. Here, suppose I'm taking time. And here I'm taking the COVID positive patients. So it was linear relationship. Linear means suppose when that wave started, the positive patients were increasing in the linear order, like with time, like suppose on 20th March, patients were 100. Okay, then on 21st March, it was suppose 200. Okay, first it was almost linear, but when the wave was at the peak time, during the peak time, it reached to this extent. That means within just 2-3 days, you were getting lakhs of patients per day. Okay, during starting of that, the number of patients were per day, a number of patients were in thousands. Okay, like they were 4,000, 5,000. But when the wave was at the peak, then during one day you were getting in lakhs. So that number of patients increased in this order. Okay, that is called the exponential means abruptly that is increasing. Here that is a linear relationship means this much. So right now you can say like you are having the linear relationship during these days, but during the third wave you will see that the number of patients will increase abruptly. Okay, so that will become the exponential. I'm using this word exponential. So this relationship, what is the relationship between the number of elements and the time complexity? That means how many operations we are performing, that is called the growth rate. Okay, so time complexity doesn't mean the exact number of operations we have to find out. Time complexity means we need to find out that what is the relationship between the number of operations and the element size. Okay, this is called the growth rate. And we need to find out the rate at which this equation grew. Okay. Why we are finding the growth rate? Because there may be some instances, suppose you take two algorithms, A and B. It may happen that when the input size is you are taking 10 elements, this A will take less time and B will take more time. But when the elements are increasing, suppose to 1,000, this A algorithm may take more time and it may take less time. Okay, then how can you say that out of these two algorithms, which one is better to solve a given problem? You can't say A is better because A was taking less time when the number of element is 10. No. So in order to find out that out of these two algorithms, which one is better, we need to find out the relationship between the complexity and the number of elements. जिसका ये relationship linear होगा, ठीक है, वो मैं बाद में बताऊंगी. जिसका relationship like right now you can say अगर relationship एक का linear है और एक का exponential है, तो which one is better? The linear one is better as compared to the exponential. So out of these two, suppose A is having the linear and B is having the exponential relationship. So you can say A complexity is lesser than that of B. Fine. 1 minute. Any doubt? Okay, suppose you need to find out the time complexity of this algorithm. What is this algorithm? You can see that I have written one sum function. Within that, I'm taking array and the number of elements in that array is n. That means I want to find out the summation of all these n elements. Suppose एक array है A. In that array, there are 5 elements, 5, 3, 2, 1, and 6. I want to take the summation of these. Okay, what would be the algorithm? That is, algorithm is very easy. I have written S is equal to 0. Sum you are initializing to 0. Then you are going through each and every element of that array. That means for loop you have written for I is equal to 0, I less than equal to n, I plus plus. Here I is 0 I have taken. So I would be less than n because array is only from 0 to n minus 1. This is 0, 1, 2, 3, 4. So 0 to 4 you are going, you are writing S is equal to S plus AI. Okay. Now, after finding the sum, I'm returning that sum. Now I need to find out what is the time complexity of this. So time complexity, what I have told you, time complexity means in simple way, you can see that time complexity means number of operations that you are performing in this algorithm. but actually we shouldn't take each and every operation. But just to tell you what do you mean by the time complexity, first I'm taking each and every operation of this algorithm. Okay, so count the number of operations that this algorithm is performing. So this is one operation, because what is that? This is assignment. I'm assigning 0 to S. So here I have written 1. How many times I'm doing this? One time. So I'm writing 1. Okay, now tell me, ये for loop है. इस for loop में I have written I is equal to 0. How many times this particular operation will be performed? Only once. Okay, so this assignment operation is being performed how many times? Just one time. So here I'm writing this is being performed one time. This initialization is also performed one time. Okay, now anyone who can tell me that how many times this operation and this operation is being performed? Yes, beta, anyone? Ajit, right? But not, okay, you first tell me, suppose here I have written I is equal to 0. So what happens within a for loop? We initialize I is equal to 0 only once. Then we compare I is less than, suppose what's the value of n over here? 5. I is less than 5. In this algorithm, suppose if there are 5 elements. So first I'm comparing 0 less than 5. So one comparison I'm doing. Then if it is less than 5, I'm performing this operation. Then I will be incremented by 1. I will become 1. Then again, I will compare 1 is less than 5. So 2 operations I'm performing. 2 is less than 5. Yes. Then again, I'm going to while loop. I will perform this statement or I will be incremented by 1. I will become what? I will become 2. Then you are comparing 2 less than 5. Yes. Then I की value 3 हो जाएगी. 3 less than 5. Yes. Then 4 less than 5. Yes. Then I will become more than 1. I will be incremented to 1. I will become 5. Okay. So 5 is less than 5? No. So how many times I have performed this operation? Yes. How many times I have performed? First, I have performed when I was 0, 1 time, 2 time, 3, 4, 5, 6 times. So how many times? 6 times. 6 times क्यों आया? क्योंकि 5 टाइम तो वो कंडीशन ट्रू थी, पर एक बार तब भी होगी ये जो कंपैरिजन है जब कंडीशन फॉल्स है, जब I की वैल्यू 5 हो जाती है. So how many times I have performed over here? 6 times. So if you are saying I is equal to 0 से start कर रही हो, तो this particular thing would be performed how many times? N plus 1 times. 6 times means अगर n की value 5 थी, तो n plus 1 times. And how many times this increment operation is being performed? ये हमेशा इससे एक less होगा. It will be n times. And how many times I'm performing this? Okay, if I'm taking this as only 1, so this particular statement is being performed n times. Any doubt in this? I'm getting some messages. Okay, so you need to write down in generalized format. Suppose if there were 5 elements, so this is being incremented how many times? 5 times. और while loop के अंदर जो भी स्टेटमेंट है वो भी 5 टाइम्स रन होगी, और ये जो ऑपरेशन है कंपैरिजन ऑपरेशन, ये एक ज्यादा बार रन होता है. क्यों? क्योंकि आपको एक फॉल्स वैल्यू के लिए भी कंपेयर करना है. ओके, सो रिटर्न स्टेटमेंट इज बीइंग परफॉर्म हाउ मेनी टाइम्स? 1 टाइम. Okay, so this is also 1 time and this is also 1 time. So 1 1 1 will become 3 plus, I'm calculating the total number of operation, n plus 1 plus n plus n. So it will become 3n plus 1. So actually you are getting 3n plus 4. 3n plus 4. Okay. But here if you will take this as, अगर इसका assignment operation अलग लोगे और plus operation अलग, and what is this? This is accessing the value of a. तो आपका 5n plus 4 आ जाएगा. But even if you are taking 3n plus 4, right now I'm assuming that you are getting 3n plus 4. So you can tell me that the time complexity is 3n plus 4. Okay, but what I have told you, जब भी आपने time complexity बतानी है, you don't have to tell me the exact number of operation. So this thing you don't need to take. क्योंकि 3n में अगर हम +4 कर भी देंगे, that doesn't make any difference. So there is no need to take this 4. So I'm not taking this 4. Even the thing that you are multiplying this n by some like constant, this is not significant. There is no need to take even this value. What is important? Important is that the relationship between the time complexity and the number n is n. That means जैसे जैसे आप n की वैल्यू को इंक्रीज करोगे, कंप्लेक्सिटी भी उसी मैनर में इंक्रीज करी है. That means you are telling me that the relationship is linear. Growth rate is linear. Growth means what? As you are increasing the value of n, how the time complexity is increasing? You are saying it is increasing in this manner. That means if n is 5, complexity is also 5. If n is 100, complexity is also 100. So you are saying the complexity is n, linear n. Okay, so that is important. That is called the growth rate. So by taking this example now, you can say, here I have written everything, that you don't need to take this 4, you don't need to take this 5. So what is important over here? What is fundamental? What is fundamental is that time is linear in n. Time complexity is linear. So this is important over here. That is called the rate of growth, or that is called the growth rate. Okay. So any doubt in this?